So the last part of the LockManager app case study will focus on the test driver implementation. And this is really interesting. And we're going to talk about it sort of at a high level first, and then we're going to dive into the code. So this is going to show how the test class works, and it's also going to show what happens when we run the class. And it's going to basically have a bunch of threads on the client side sending post requests to the microservice and doing things either requiring a single lock or multiple locks. So let's talk about this first. The Spring Boot, the LockManagerTest class is a Spring Boot test class. It's annotated with Spring Boot tests, as you'll see in a moment. And that is used to exercise and test the features of the LockManager application. And here are the key methods it's got. So by making it a Spring Boot test, it will load the application context and start up the LockManager application and all the controller and service stuff, and then make a bunch of calls to send post requests to that. These are the two methods that are most interesting. They're the ones that are going to basically acquire and release multiple locks and acquire and release single locks. So we're going to spend a little time talking about that. And all these methods are going to be used to see what happens under load. So we're trying to emulate the scenario where we have multiple processes, multiple clients descending upon the single instance of the LockManager service. However, in this case, we just have a single client, so we use multiple threads to make that work. So here's the test single acquire and release method, which is an annotated test method, so it runs automatically. And what it does is it makes sure that multiple client threads can acquire and release a single lock concurrently from a LockManager. Here's what it looks like. We have the number of locks we want to have, which in this case is 2. And we create a LockManager, which will have a permit count of 2. This call, of course, is a proxy call, which goes over to the server and gets the result, which is the LockManager. And then we use a Java parallel stream for 4 clients. So we're going to have 4 simultaneous threads going, because I've got plenty of threads on my 10-core laptop. And in parallel, each of those threads, each of those clients, will call the test single lock method to test acquiring and releasing a single lock. But we'll have multiple threads going in parallel. And since there'll be 4 threads going in parallel, but only 2 locks, then there's going to have to be a little bit of blocking on the server side in order to fulfill that request. Here's what test single lock looks like. As you can see here, we pass it the client and the LockManager, and all it does is it goes and makes an acquire call with the LockManager to try to get 1 lock. And when it gets it, it logs some stuff, which I omitted here for brevity, and then it releases that lock back to the server. Once again, the mlock API acquire and mlock API release methods are in fact proxy calls through the Lock API automatically generated proxy that we talked about. So that's single locks. Then there's also a test that tests multiple lock acquire and releases. So this ensures that multiple client threads can acquire and release multiple locks concurrently from a LockManager. So in this case, we make a LockManager that has 4 locks instead of 2, so it's got twice the amount. We're going to have 8 clients that are all going to run in parallel. Again, I have enough threads to do that, so they all truly do, in fact, run in parallel. And each of those client threads is going to call this test method, which will acquire and release multiple permits, and each one's going to try to get 2 permits. Here's what the test multiple locks method looks like. As you can see here, we take the client, the LockManager, and the number of permits that it wants, and we call the acquire method that takes in a permits count. So now we're going to have to block the client until it can get 2 permits. Now remember, we have 8 threads that are running. We got 4 locks in our LockManager, and each client wants 2 permits. So we're going to be able to satisfy everybody, but they're not all going to get satisfied at once. And if you recall the way this works on the server side, the acquire method for this thing is going to sit there and try to get the locks. If it can get all 2 of them, it's fine. But if it can't get them in a non-blocking way, it'll release them and then go back again and try to get them again. So this is going to really push the server implementation quite a bit to see how it behaves when we run this with multiple things happening. So let's go ahead now and take a look at the implementation of this, and I'll also run it as well. So here we are finally about ready to look at the LockManager tests. I'm going to start running this in the background because it takes a little while to run, and I'll just show you this real quick. So LockManagerTest is a Spring Boot test. It's going to automatically launch and load the LockManager application class, and it's going to work on a well-defined port that we have in our properties file. We're going to auto-wire the lock API. We saw how we did that using the client bean get lock API. That's what's used to auto-wire that. And then we define the permits count, the number of permits to acquire and release simultaneously. And we'll use that for the multi-version. And then here are the various test methods. You can see we have this annotated with a test annotation, which says it'll automatically run using the JUnit test harness. And it prints a diagnostic. These are the various parameters that it's going to use. It creates a lock manager that has 2 locks. Then for 4 clients, it'll run things in parallel, testing a single lock. We looked at that just a second ago. That's super simple. The only thing that's different from the walkthrough I did in my slides is I show some logging calls here so we can see what's actually happening. And then the one that works on test multiple acquire and release, that's also a test annotation. It has a larger number of things, including multiple permits it wants. It calls test multiple locks, and that just goes down and uses the other version of acquire. So while that was, we were walking through that, let's just go take a quick look at what comes out of here. And so you can see there's lots of debugging information that's going on. And I'm not going to belabor all of this, although it is kind of interesting to see what's going on. So you can see here, this is on the client side. We start testing the multiple acquire and release method first. And that's going to involve calling the lock controller to create 4. It's going to have 4 permits for locks in the lock manager. And you can see that it tells us what the locks were and what thread this is occurring in. You can see that these things are occurring in HTTP worker threads. Very important to note that. Then what's happening over here is now we are starting the client on the, now that we're starting the client, stuff's running again. You can see that this is running in the fork join comment pool. These are all calls that are taking place on the client. You can tell that because it's the fork join pool, which is parallel streams. And then we come back over here, and now you can see we're in the server side again. Now we're in the controller, and you can see here in parallel, all these calls are coming in to the server. And notice, if you will, here, they're all running in different HTTP worker thread contexts. So each of these is a separate HTTP worker thread. We know that because of the name that we have here, HTTP, NIO, et cetera, et cetera. So these are all separate threads. They're all running in parallel. And remember, all they do is they turn around and they call into the lock service acquire method. And you can see, if you look carefully, that the calls are also running in the same thread. So like here's thread 48. There's where 48 is. That's in the lock service acquire. And now you can see what's happening on the server right away, because we're going to spawn some threads to run in the background. Deferred results are being returned immediately by the controller. So they're coming right back. However, now we go into the fun part. So now we're having the lock service starting to do its thing. And now you can notice also that the lock service, once it's up and running, is running in a virtual thread. So the lock service, when we created that runnable and submitted it to the executor, these operations are running in a virtual thread. And there's just a whole bunch of stuff that's going on over here. You can see that now we're back on the client side. A couple threads got their locks right away. And on the server side, then things are going to kind of loop and try to get the permits that they need. Down here, you can see that the client is releasing permits, and the permits are now being released on the server side, and so on and so forth. So I won't belabor all of this stuff, but it's really interesting to kind of walk through all the stuff that's going on. You can see there's a lot of things happening concurrently because of the fact we're having more threads requesting permits than there are permits to dole out. So there's a lot of stuff happening on the server side, less stuff happening on the client side. And then once we're all done with all of that stuff, then we're going to go ahead and do the single acquire and release stuff. And that is much simpler because we're only acquiring one thing at a time. So we're acquiring something, releasing it, acquiring something, releasing it. So it takes much less time to run and is not nearly as complicated. But I just wanted to kind of show you what this looks like when you actually log it. And now if we were really trying to run this program for real, we would probably write a little script to go through here and parse the output so we could see what was going on the client side, what was going on the server side, which would be invaluable if we were trying to debug what was going on. And to be perfectly honest, when I wrote this code some time back, I spent a lot of time as I was debugging it, trying to figure out what was going on, and being able to log stuff in this manner was invaluable, because otherwise I would have just been staring at code, which is not the best way to try to debug concurrent defects in your applications. Okay, so that is the end of that walkthrough.